Hello students, welcome back to IT Foundation classes. I am your chemistry faculty S. Mohan, right? And grade 6 chemistry we are doing with basic importance of chemistry, right? And in that we are completed the first synopsis, that is first lesson, and we started the second lesson. In the second lesson we are discussing some of the important apparatus that what we use in the laboratories, and along with that we discussed some of the topics like okay, these are all we discussed. So we go to the today direct topic. So matter we discussed and the types of matter also we discussed. So yesterday we also discussed about the solution, right, and solute, solvent examples, and universal solvent. What is the universal solvent? Water. Why it is called? Because it has a capacity to dissolve so many things in it, right? So mostly used solvent in the industries is water. So that's what water is called as a universal solvent, right students? So till here we discussed in the last class. So today we go to the next topic. What is the next topic? Okay, physical change and chemical change. Wow, a very nice topic. So physical change and chemical change. So students, did you listen about the changes? Okay, so here we have one more chapter, of course, that we study later. So that the chapter is changes around us. Changes around us. Okay, so we can see so many changes around us, right? So many changes. So these changes are classified in different ways, like slow change and fast changes, fast reactions and slow reactions, desirable, undesirable. So like this, the changes around us are classified in different ways. Among them, one of the most important one is a physical and a chemical change. Physical and a chemical change. So students, what is the physical change? So students, here physical change means if there is a change in the physical properties of a matter. If there is a change in the physical properties of a matter. What comes under physical properties? Size, okay, shape, state, okay, etc. So they comes under the physical properties. What are they? Size, shape, state. If there is a change in this type of properties, okay, so in the physical properties like size, shape, state, etc., then such type of change is called physical change. Physical change. Like example, if I take the water, okay, if I take the water, and the water is in which state? Liquid state. Water is which state? Liquid state. Now this water, if I freeze, okay, if I put in the refrigerator and if I freeze the water after 1 hour or 2 hours, after some time what happens? It becomes ice. It becomes ice. So what change do you find? Liquid to solid. Ice is what? Solid, right? So the water is changed from liquid to solid state. Again, if you bring the ice out of the refrigerator and keep aside outside for some time, again it turns into liquid. Yes or no? So here water is changing into ice, ice is changing into water. So where there is change? Only physical properties, that is the state. Yes. So there is no change in the composition. Is there any new thing is forming? No. So here no new substance is formed, students. No new substance, okay, is formed here. No new substance is formed here. Okay. So water only, but only turning into the physical state, means into the solid state, but there is no change in the composition. Okay. So this we can say that no new substance is formed. Instead of that we can also say that okay, no change in composition. No change in composition. Composition means what? How it is made up of. You know, I think that water formula is what? H2O, right? Did you listen? water formula is H2O. Okay, means 2 hydrogens and 1 oxygen. That's the formula. If I ask you, if the water after putting in the refrigerator, it becomes an ice. If I ask you, what is the formula of an ice? Then what do you say? Same, H2O. Yes, so there is no change in the composition. So new substance, no new substance is forming and no change in the composition. So that is about the, okay, physical change. And this is what? Temporary change, students. Which change this is? Temporary change. What is mean the temporary? Only for some time. Okay, up to as long as you put in the refrigerator, it becomes ice. It will be in the form of ice. But if you once get it out of the refrigerator, this becomes again liquid. Yes or no? So the change is not permanent. Permanent means what? Forever. Okay. So if you change the water into the ice, does this water exist forever in the ice? Means a solid state only, as a ice only? No. Again, if the conditions changes, then again it turns into the liquid water, right? So this type of change is called a temporary change, and this change is reversible. Okay, reversible. Reversible means what? Again, it can get back to its original substance. Water, if I am freezing, that becomes ice. Again, if I brought it out, if I bring it out, again it becomes water. Water. So reversible, reverse it's coming. Okay, so this changes is solved reversible. And example, what you write for this one? Example, you can write melting of ice. Otherwise, you can write like, okay, we write like this. We write here, we'll write with some red pen. Okay, red pen. So here you see, this is the water, okay, which is in liquid state, right? If I freeze it, it turns into water, ice. So that's called water, solid state. Okay. Again, if I get back this side, means if I put outside, again it becomes water. If I boil the water, water becomes vapor. So vapor is which state? Gaseous state. Again, if I condense, do you know the condensation? Okay. If I condense, again it becomes a, okay, liquid. So this, so water can change into ice, ice can change into water. Again, water can be changed into vapor, vapor can be changed into water. Okay. So this type of change is called physical change. Is this clear, student? Physical change. Okay. Now let's come to the chemical change. What is chemical change? Chemical change means what? So here, if there is change in the chemical properties, of course physical properties also sometimes it will be changes. So there is a change in both physical and chemical properties, you say. Okay. If a matter undergoes both the physical and the chemical properties, okay, then that's called chemical change. Okay. So it's undergoing change in both physical and chemical properties. Okay, that are undergoing change in both the physical and chemical properties. Okay, but here what happens? A new substance will form here. What happens here? A new substance will form. For example, students, if you have a magnesium ribbon, did you see the magnesium ribbon? Okay, so once if you go to the lab, okay, then you see the magnesium ribbon. Okay, that's magnesium. If you burn the magnesium, okay, so it burns with a dazzling flame. A white flame will come and it burn. Okay, and when it burn, here in the chemistry, normally we say that it burns. But in the chemistry, what do you say? Instead of burning, so we say that magnesium reacting with the oxygen, because we are burning in air, and you know that air is required to burn anything. Yes or no? So here, so air is required. So yeah, magnesium burning in air means what? Magnesium is reacting with the oxygen to form a magnesium oxide. What it forms? Magnesium oxide. So here a new substance is forming. Okay, simply say, okay, magnesium, if you don't know, then we take one simple substance. So for example, you take one paper. Okay, here I have a paper. Okay, I'm not doing this experiment showing that. So this is a paper. Okay, this paper, if I burn it, okay, if I burn it, then what happens? It becomes an ash, right? So similarly, if you take wood, wood is nothing but a carbon, right? So if the carbon is burnt, you know that when carbon is burned in oxygen, it forms carbon dioxide gas. Yes, this I think you know everyone, carbon dioxide gas. Okay, so here carbon is burning in presence of oxygen forming the carbon dioxide. Means what? Carbon reacting with the oxygen and forming the carbon dioxide, which is a new substance, right? So here in the physical change, what we said here, no new substance is formed, but here a new substance is formed here. Okay, new substance is formed. Alright, and here no change in composition, but here what happens is there is a change in composition. Change in composition means what? We are taking the carbon and oxygen individually, but these both are reacting to form the carbon dioxide. Alright, so a new substance is forming. So this is a new substance is forming. So there is a change in the composition. Okay, and here it is a permanent change. What it is? A permanent change. Permanent means what? Okay, permanent is what? Forever. Yes, for example, just I told you that if you take a paper and if you burn, then what happens? It forms an ash. Okay, so this ash again, can you convert into paper? Is it possible? No. Right? So that is a permanent change. Okay. Mostly chemical reactions are permanent, and few reactions are reversible or there, that we discuss in the higher classes. Now this is a reversible we said, but here it is irreversible. Permanent now. So once if it is changed, so this is irreversible. Means what? It do not come back again to its original position. Example, burning of coal or magnesium and so on. Clear, students? So these are about the physical change and chemical change. Are you understood the physical change and chemical change? Any doubt? Once see here, just 1 minute, once go through this one. Right? Chalo, now let us see. Oh, again we have the physical change and chemical change. Okay, now let us discuss one by one here. Chalo students, now see the physical change. So the physical change means what? A physical change is a change only in physical properties like shape, size, even you can include state also. Even include what? State. Okay. So state also. Okay. A physical change is a change only in physical properties such as a shape, size, state, etc. Right? And a physical change is a temporary change. Temporary means what I said? For some time. Okay. If the conditions are changed, again it comes to its original stage. Okay. And when a substance undergo a physical change, its composition remains the same. Now example you see here. Here what is this? This is an ice. Okay. So what is this? This is ice. Okay. Ice in which state? Solid state. If it melts, what happens here? You can see here, it's turning into the water. Alright. So water, if you freeze it, it becomes ice. Ice, if you bring out of the refrigerator, then it becomes water. So here water is changing into ice, ice is changing into water, but no new substance is forming. Only the state is changing from water to ice. Means what? Liquid to solid. Ice to water means water. Solid to liquid, liquid to solid, solid to liquid. But no new substance is forming and no change in composition. Here also you can see, if you are boiling the water, okay, when you boil the water, then what happens here? Water is converting into the vapor. See, water is converting into the vapor. For example, if you think you can collect the vapor and if you condense it, condense means what? Cool. Then again, can you change the vapor into the water? Yes, of course. We can change again the vapor into the water. So here water is liquid. It's changing from liquid state to gaseous state. Again, if you cool it, gaseous state to liquid state. So meaning is what? This change is temporary change, not forever. Okay, it's only a temporary, and as long as if you maintain that particular condition, it will be in that particular state. If the conditions are changed, again it come back to its original state. Clear, students? So that's about the here So when a substance undergoes a physical change, its composition remains the same. So here also if you take the water form, water, just now we said, water formula is what? H2O. Water vapor formula, again H2O. Water formula, H2O. Ice formula, H2O. So there is no change in the composition, right? A physical change, no new substances forming. And a physical change easily reversible. Reversible means what? Again coming back to its original state. Water naturally exists in the liquid state, but we can convert it into vapor, we can convert it into solid. But after, however, the conditions change, again it come back to original state. Okay, so original substance can be recovered. Some examples here: freezing of water, melting of wax, boiling of water, etc. Melting of wax also. Okay, so you can take the candle wax and you melt it. So on melting, what happens? It turns into the liquid. Again, if you wait for till cooling, again it becomes the solid. Yes or no? Generally, you use a coconut oil. See, one more example. You use a coconut oil for hair, right? So, generally coconut oil in which state? Liquid state. But did you observe in the winter season what happens in the early morning if you would like to apply the coconut oil to your head? When you open the coconut oil bottle, then what you'll observe? It will be solidifies. Yes, it becomes white. Okay, like ghee, right? So it becomes white solid. Again, if you want to apply, then what you do? You just melt it. On melting, again it comes to its original state. Yes or no? So during the winter, due to the atmosphere becomes very cool, so this coconut oil turns into the solid. So liquid is turning into the solid. Again, when you put for some time in a sunlight, again it turns into liquid. So where there is change, there is a change only in the physical state but not the chemical state. Okay, physical properties but not in the chemical properties. Clear? That's all. So that is about the physical change, students. Any doubt here? So once you go through this slide, so all important points are there. Try to understand. The picture is also there. You can see the picture. By seeing the picture also you can understand them. Okay, what is a physical change and a chemical change? Clear, students? Any doubt? Chalo, let's go to the chemical change. Chalo, chemical change. So chemical change, you see the picture first. So what picture can you see here? So you can see the coal or wood is burning, right? So here coal or wood consists of what? Carbon. Carbon is burning. Burning means what? It's reacting with oxygen. So it react with oxygen forms what? Carbon dioxide gas. What it forms? Carbon dioxide gas. So carbon dioxide gas is formed. Can you convert again the carbon dioxide gas into wood? No, it's not possible. So once it's converted. This is permanent, right? So there is a change in the composition, right? Chalo. And here you can see so the chemical reaction is taking place between the copper and nitric acid. Okay, so see chemical reaction is taking place and the brown color gas is releasing. That's about of nitrogen dioxide. What is that? Nitrogen dioxide. Okay, chalo. So chemical change. Now you see once again these definitions and everything. A chemical change is a change in which both the physical and the chemical properties of the substance, including composition, changes, students. So just now I told you that in the chemical change, there is a change in the physical as well as chemical properties. Okay, along with of course composition also. The composition is also change. Okay, and the change is a permanent change. Just now I told you that this is a coal on burning, it turns into heat and carbon dioxide. Again, can you convert the carbon dioxide into the coal? No. Okay, so that's a permanent change. When a substance undergoes a chemical change, its composition is changed. Okay, and a chemical change is always accompanied with one or more new substances. Yes, one or more new substances will form. For example, here you see coal is burning, so we are getting a new substance called carbon dioxide. Yes, so like so many examples of the students, but here I am giving carbon dioxide because you are in the 6th class. Okay, so I would like to, I'm trying to explain you only the things which you know and which you can relate to your existing syllabus. Okay, right. Then come to the chemical changes, the irreversible. Irreversible means what? Again, we cannot get the original substance back. And a few examples, see digestion of food. Wow. Okay, digestion of food. Yeah, very good example, no students? So, if you eat the food, Okay, if you eat the food, then what happens? It gets digested. What is the digestion? So food is converting into energy. So see, we are doing so many things, no, in a daily life. So since morning onwards, morning you get up and take the brush and take the bath and okay, eat and take the bag, go to the school, write, listen, play. So many things you do. For all these activities, you require the energy. From where you are getting energy? By the food, right? And this food, it will be digested, and when it is digested, it gives the energy. Of course, along with the energy, so many things it's provide because now we are some. Last year you are little smaller, now we are in little grown, and the next year it will be grown up like this. As so, there will be a change, right? Okay, so this digested food will be useful in various ways in our body. Okay, now once the food is digested, can you change that digested food again into normal food? No. So there's a permanent change. Okay, burning of coal, here it's given rusting. Do you know about rusting? Yes, I think we discussed rusting somewhere. Where? During alloys, in the chemistry, importance of chemistry we discussed. Okay, yeah. So rusting, I think everyone knows about the rusting. So for example, you take this iron. Imagine this is an iron rod, and this iron rod, if I place somewhere in the moisture for some days, few days, that get rust. Yes. So rusting means what? The total iron is getting spoiled, damaging, right? So that is rust. Here, how the rust is formed? Yes, iron when react with the moisture, air or oxygen, then it forms a rust. Okay, and how to prevent it? This also shortly explained you by applying the painting, galvanizing, oiling, greasing, alloying. This all I explained in the previous class. Once recollect it, right? So that's also, so this is about the chemical change. Okay, once see this chemical change tried also, and try to read all the points once and understand the concept, and hope you can also differentiate between the physical state and physical change and chemical change. Yes. Okay, let's go to the next topic. Acha. So with this second synopsis is done. Means second chapter is done. Now we are going to solve some numericals. Chalo. Identify the apparatus with the hints given below. Some hints are given. So already we discussed the important apparatus what we use in our chemistry lab, right? So now we see here, it's a kind of iron tongue provided with wooden or plastic handle. So there's a handle and wooden tongue will be there. Tongue. Okay, and it is used for holding the test tube. Holding the test tube when the substance is being heated. When you want to heat something in the test tube, then you don't heat directly by holding with your hands. Yes or no? So you need something. Okay, to hold it in a hand. What's that? Good. So that is the test tube. No. Test tube holder. Yes. This is a test tube holder. So the answer is 2. Second option. Correct? Chal. Second one, a glass container with a spherical bulb and a narrow cylindrical neck. Ooh, a glass container with a spherical, spherical bulb like round and narrow cylindrical vessel is called what? Funnel? No. Conical flask? No. Round bottom flask. Okay, so this is a round bottom flask. Okay, next, a cone shaped flask with a flat base. Now this is flat base and provided with the cylindrical neck is called cone shaped flat vessel, and there is a neck to hold and shake it. What is that? Funnel, conical flask. So this answer is conical flask. Right, students? Conical flask. An open glass container. Okay, this is open glass container means what? A container. One side is closed, another one is open. Cylindrical in shape. Okay, cylindrical in shape and provided with a small lip like to pour. Okay, lip like it is of pouring out liquids is called beaker, funnel, chain dish operating. So this is beaker, students. What is this? Beaker. Okay. Now, solids are held tightly together. By the solids, in the extra we discussed, solids in the solids atoms are closely packed with each other. Why? There is a strong force of attraction. Yes, did you remember? Acha. So solids are held together tightly to give definite shape and volume, indefinite, definite specific gravity, refractive index. So definite shape and volume. So this is the right answer, students. Definite shape and volume. Dash is known as universal solid. Which is known as a universal solid? Did you remember? Water. Is there our water? Yeah, the water is there. So this is our. The formation of new substance in a change is called, just now we discussed, physical change and chemical change. A change in which a new substance is formed. In which a new substance will form? So that is a chemical change, right? So chemical change is the right answer. Clear, students? So these are the answers for the, okay, first 7 questions. Okay, these are the concept based questions which are completely based on your concepts what we discussed. Alright, chalo. Now, any doubt in this one? Let's go to the next one now. What is the next one now? Chalo. Now exercise 1. Here little harder questions comparatively to that one. So good laboratory apparatus is made from, see, laboratory apparatus should be made up of, glass, that okay, they will be made up of glass, okay, and here the glass can be used for heating, boiling something, okay, so here there should be a strong, the glass should be strong, so which glass is used? Flint glass, Pyrex glass, soda glass and hard glass. So in this Pyrex glass is important one, so Pyrex glass is the answer, okay. Next, so that's the second one. Now, the Bunsen burner burns with what? Burns with water. Yeah, generally we use the LPG only, the Bunsen burner. So this at home, while your mom is cooking, I think you might have observed. So the flame will be in which color? Good, blue color. So that is blue color flame will be there. Right. Third one, a circular made. Okay, a circular mark. Made in pipette neck signifies, okay. So pipette, a glass tube, like I said, okay, in the middle there is a bulb like this there, and there is one mark is there. So what purpose that mark is there? Okay, density of liquid, no, mass of the liquid, no, volume of the liquid, how much volume that liquid is there, so we can come to know, okay. If you are taking, for example, 50 ml pipette or 25 ml pipette, that mark indicates that till that mark it is exactly 25 ml or 50 ml. So that is to volume of the liquid. Which meniscus, okay, is taken for measurement of the colored solution? Generally, we take the upper meniscus, students, for this one. A small piece of stone sinks in water. Why it sinks in the water? Heavier, lighter, smaller, larger. Because heavier. Okay, when you compare this one, the small piece will be, it sink means what? It is heavier than the water, then only it will sink. Okay, so the answer is heavier. First one is the answer. Dash acquire the shape of the container. Which acquire the shape of the container? Solid, liquid, gases, stones. Generally, liquids. Liquids, okay, acquire the shape of the container, where the gases can occupy the entire volume, whatever the room is there, so that entire volume. The molecules of dash have a larger space between them. This also we discussed in the solids. Atoms are closely packed. Liquids, moderator, and gases very far, so they have a lot of space between the molecules. So that's about the gases. So these are the answers, students. Once you check these answers also, correct? Anywhere do you have any doubts? No. Okay, good. Then we go to the next slide. Okay. The room temperature, at room temperature coconut oil existed. At room temperature means don't think it's a winter. Okay, normal day. Normal day, what will be the temperature generally? Generally 25 to 30 degrees Celsius. At 25 to 30 degrees Celsius, coconut oil exists in which state? Solid, liquid or gas? Coconut oil, liquid state. Very good. A homogeneous mixture of solid and solvent. Yeah, a homogeneous mixture. Yesterday we described the solutions, right? A homogeneous mixture of solid and solvent is called what? Solution. Very good. So this is solution. A liquid in which the substance get dissolved. A liquid in which the substance get dissolved. So liquid means which is in more quantity, right? So that's called what? A solvent. Okay. And the substance dissolved in the liquid. Which it dissolves in the liquid? For example, in the sugar water. sugar. Okay, so that is called what? Solute. So this is solute. Acha, they are given options. So I am thinking fill in the blanks. Okay, so your options, first option should be solution, second solvent, third is solute. Solution, solvent, solute. Solution, solvent, solute. This is wrong. Solution, solvent, solute. Yeah, so this is our right answer. Okay, this is a right answer for this one. Now next one, we smell the fragrance of the flowers, perfumes and the coffee etc. because of the molecules spread easily. Okay, of which molecules? Solid, liquid, gas? Gases. So the answer is gas is the right answer. Gases. Pipette is used to measuring what? Pipette, just now we discussed. It is used to measure the fixed volume. The answer is 1. Numerical type, depending upon the intermolecular forces. Intermolecular forces, there are dash states of matter. How many states of matter? 3 states of matter. Solid, liquid, gas. Right? So there are 3 types of matter. So this answer here is 3. Okay, students. So once go through this one also. Check these answers and check the questions. Okay. Chalo, so new synopsis. So with this we completed, students. So with this, the second lesson, or we can say in terms of synopsis, the second synopsis we completed. So the second synopsis consists of 3 parts. So this is a third part. In the first part, we discussed of the some commonly used laboratory equipments, or you can say that apparatus. In the second part, we discussed about the classification of matter, solutions and everything. The third part, we discussed about the physical change and chemical change along with this exercise. Okay, so with this we completed the second lesson or second synopsis of the chapter Basic Importance of Chemistry. Right? Okay, students. So with this we stop and we meet in the next class. Till then, take care of yourself and study well.